Question 5 of this exercise is a very interesting question on mensuration, on finding volume, which is based on AP. And here's what it says. Here's what the problem statement says. A small terrace at a football ground comprises of 15 steps, each of which is 50 meters long and built of solid concrete. So look at this figure here. So we have this terrace of steps, and the width of each step is 50 meters, which is what is shown here. And each step has a rise of 1/4 meters and a tread of 1/2 meters. So rise means vertical extent of each step is 1/4 meters, and tread means that the horizontal width or the horizontal extent of each step in this direction is 1/2 meters. So what we have to do is we have to calculate the total volume of concrete required to build the terrace. So we have to calculate the total volume of this structure that you see in the figure. Now what we're going to do is we are going to take a closer look at this structure. I'll magnify it for you, and then we will deconstruct this structure and imagine the various parts that come together to form this structure. Okay, so let's do that. So here's a magnified version of this structure. So if you look at this first step here, the height of this step is 1/4 meters, and this extent, the horizontal extent of the step is 1/2 meters. So and we already know that this width of the step is 50 meters. So if you imagine just this first step, this basically forms a cuboidal structure with the dimensions 50 meters, 1/4 meters and 1/2 meters. So the amount of concrete just to build this first step will be 50 into 1/4 into 1/2, these many meter cube. So 50 into 1/4 into 1/2 is 50 into 1/8 or 6.25. So 6.25 meter cube is the volume of concrete that will be required to build the first step. Now I want you to focus your attention on the second step. So what are the dimensions of the second step? So here I've again highlighted it for you. So the width of the second step will be 50 again, because that's constant, and the horizontal extent of this step will be 1/2 again. But what will be the height of the step? So the height of the first step is 1/4. So the total height of the second step will be 1/4 plus 1/4 or 1/2. So this will be the height of the second step. So the total volume of the second step, the total amount of concrete for the second step cuboidal structure will be 50 into 1/2 into 1/2. That's 50 into 1/4 or 12.5 meters cube. So this is the volume of the second step. Now similarly, if you focus your attention on the third step, you can easily find the dimensions of the third step. So this will be 50 again for the width of the step, and the horizontal extent of the step will be 1/2 again, so into 1/2. But the height of this step will be 1/4 plus 1/4 plus 1/4. So 3 times 1/4 or 3/4. So 50 into 1/2 into 3/4 meter cube, and this is equal to 18.75 meter cube, and so on. So you can think about each step like this and you can find out its volume. So what you see is that for each step, 2 of the dimensions are constant. So you have this 50 meters as constant, and you have this 1/2 that you have the horizontal extent of the step, which is what is referred to as the tread of the step. This is constant. What is varying is the height of the step. So from 1/4 it becomes 1/2, then it becomes 3/4. In the next step it will become 1, and so on. And we will continue this sequence up to the last step, which is what I've shown you here, in which the only dimension that will be different from the other steps is the total height of this step, which will be 15 times 1/4. So what you get as the volumes, as the sequence of volumes, is 6.25, 12.5, 18.75. So if I write this sequence out, so we have 6.25 meter cube, then we have 12.5 meter cube, then we have 18.75 meter cube, and so on. And this will continue for a total of 15 terms. So we see that this is an arithmetic progression. The first term is 6.25 and the common difference is also 6.25. So now it's easy to find the total volume of the structure. So let's do that now. So the total volume of the structure can be written as 6.25 meter cube plus 12.5 meter cube plus 18.75 meter cube, and so on. And this progression will continue for 15 terms because there are a total of 15 steps. So let's use the formula Sn equal to n by 2 times 2a plus n minus 1 times d to sum this arithmetic progression. So we have n is equal to 15. So 15 by 2 times 2a. So a is 6.25. So 2a is 12.5. 2 times 6.25 plus n minus 1 into d. So n is 15. So n minus 1 is 14 into d is also 6.25. The difference between any pair of consecutive terms. So this is also 6.25. So we get 15 by 2 into 12.5 plus 14 into 6.25 is 87.5. So this is what we get. Now beautifully what we get is this sum 12.5 plus 87.5, which is actually equal to 100. So I think the values were chosen so that we get this easy value to calculate with. So we get 15 by 2 into 100, which is equal to 15 into 50, which is equal to 750 meter cube. So the total volume of the structure is 750 meter cube. So this means that the total volume of concrete required to build the terrace will be 750 meter cube. So once again, keep in mind how I solved this problem. I basically deconstructed this structure as as a series of volumes which form an arithmetic progression. And the way I did that was I looked at all the steps forming this structure and writing the volumes of those steps, and from there I created this arithmetic progression of 6.25, 12.5, 18.75 and so on. So as an exercise, as a follow-up to this question, try working out this problem once again. So you might have understood it by watching the video, but it will be a very good idea for you to work through the whole problem from scratch once again. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.